Broadcasting live from SETI Alpha 6 in the Andromeda Galaxy, this is Mr. C.
Let's go.
Well, here we are, Tuesday already. Pretty exciting, and I do have a guest today, so not going to give you any hints, but this is a very famous guest that I've used year after year, and a really good teacher, too. So that's all I'm going to tell you. It'll be really cool in a minute. I know you've already got these things out and ready to go. You've got your lesson planner out. You've got your homework in already. Way to go. You've been impressing Mr. G with how you get after your do nows. Keep impressing him because then it impresses me. So way to go. So you've got your journal out and you're going to use that journal in a number of ways. So, and we'll talk about that in a little bit. In fact, in your journal, you might find the section about Isaac Newton and maybe put a marker in there, and then also your journal section about the characteristics of the moon. You've already got your white sheet numbered to 10, and I have a Big 10 review questions for you. Then I'm going to come back and remind you about the week. Okay. Big 10 questions now, and here is my offer to you. If you get a 9 or 10, you can turn it in for a grade. One of your last grades of this first quarter. Okay, here they are. We'll go quickly. So since it's an optional chance for you to get a score, I can't be really slow on asking these questions. So you're going to have to know them and get them down quickly on your white sheet. Number one, the 3 G's that involve the glue of the galaxy. So what is it? That's number one. The glue of the galaxy. What is it that holds the galaxy together that the Lord used when he created everything, and he's continuing an ongoing use today? Number two, what do we call it? One object going around another object, held in gravitationally by the one object and going around it. So it's that motion around one object around another. Number two, that was number two. Number three, spinning on its axis, a moon or a planet or a star spinning on its axis. What do we call that? Number four, Newton, Isaac Newton, came up with a number of science principles. So what is just the name of a basic principle? Any science principle that he came up with, and any science principle that we use today. Now, specifically his principles, so I'm writing down, making a little note to myself. One of his principles involved something about gravity. What was it called? It's a principle about gravity. And what exactly is it called? And then number six, what do we call, what is the name for his principle about moving objects? What is that called? That's number six. Number seven, what do we call the moon getting bigger and bigger and bigger? More and more lit. One word answer, number seven. What's that called? Number eight, What do we call the light on the moon shrinking? So, shrinking. What is that called? Number 8. Number 9, what do we call an almost full moon? Not quite, almost full on either side of the phase known as full moon. So what is it called? And then number 10 is a freebie. I'm just giving you a point. So you just needed 9. So you get number 10. Everybody gets it? Awesome. So a freebie on that. So here we go. Number 1. What is, and would you be honest here, please? You don't need a red pen. I trust you. Please be honest. But you can just grade with a pen or pencil, whatever is in front of you. Or if you've got a red pen handy that you can whip out really quick, great, go for it. Okay, so number 1, what is the glue of the galaxy? 3 G's. Gravity is the glue of the galaxy. Number 2, one object going around another one. What do you call that? That is revolve or revolution. Number 3, spinning in place. What do you call that? Rotate, 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 or rotation. Number 3, rotation. Be honest. Be honest. Be honest with all of this. Number 4, what do you call a principle in science? Isaac Newton had several of them. A principle in science that you can always count on. So it just always works. So what do you call it? That would be a scientific law. So number 4 was law. So what was Isaac Newton's principle about gravity? Now you've mostly got to get this right to get the point. Okay, or otherwise you get half a point. It's the universal law of gravitation. The universal law of gravitation. Isaac Newton's law of universal gravitation. You could write it either way. Now if you've got the whole enchilada there, give yourself the point. If it's partly right, give yourself half a point, 1/2. Okay, number 6, Isaac Newton's scientific principle about motion. It's just called, you know what, I'm going to change it. I'm going to let you do an answer right now and just do half of it. Here it is. And I think this will make sense. What did Newton say about an object that's at rest or not moving? What did he say? So write it down, a little bullet fact. Number 6. Wet my whistle. So, and got a little bit of allergies, so dry throat. So number 6. So what did he say about objects that aren't moving? Objects that aren't moving will continue not to move or remain at rest unless acted upon by a force. Now if you had the first part, objects at rest will continue at rest, that's half. And then if you had unless acted upon by a push or a pull, a force, then they'll continue to be at rest. So that was number 6. Be honest. Put a question mark by it if you're not sure and turn it in. I'll sort of be the final judge. All right, number 7. The moon growing in how much is lit up. That would be waxing, 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 waxing. And then on the other side, waning, 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 waning. So number 7, waxing, waxing, waxing. And then number 8, waning. So just those 2 words. Number 9, what do we call an almost full moon on either side of full moon? It's a gibbous moon. You don't have to spell it exactly right. Gibbous. Gibbous. So if you've got a 9 or 10 on that, remember I gave you number 10 as a free point. If you've got a 9 or 10, name date period, upper right hand corner, and pass that into the center. Pass it into the center. Hope you did okay. You know I like to review key ideas a lot. Okay, find your journal section on Isaac Newton. You saw a little video on Isaac Newton, And here were a few things I want you to stick in your journal on him. If you don't have these things, add them. In fact, how many do you have, Mr. C? I've got 6 things. 6. Here they are. Number 1, he was English. He was from England. So number 1. Number 2, he was a mathematician. A brilliant, actually, mathematician. Number 3, he was a brilliant scientist. So 1, he was English. 2, he was a mathematician, and he used his math in his science. And that's one of the things that made him, maybe, some people consider him the greatest scientist who ever lived. So, and one of the reasons is because of his using mathematics and combining it with a scientific method to prove a number of things, a number of questions that he had. Number 4, he was a professor at Cambridge University. Cambridge, very famous university in England, to this day actually, Cambridge. Now, by the way, C.S. Lewis either was a prof at Cambridge also, or Oxford. Those are like 2, like just all-star universities in England. Number 5, he was born in 1642. To give you an idea, kind of late in the Renaissance, I think, or middle to late Renaissance. And this might be the biggie about Isaac Newton. He was a God believer, maybe born again, not totally sure, but he so much believed in a God who had designed and created the universe. In fact, in the latter part of his life, the kind of curiosity that he had was focused on what God did exactly to create the universe and how he did it exactly. Kind of the particles that he made things out of. So, big deal. If you ever hear this, well, no, really, smart scientist believes in creation. Oh, really? Maybe the smartest, greatest scientist who ever lived. In fact, the 2. Einstein on the list too. Both those guys, Newton and Einstein, both believed that God had created the universe and were trying to figure out exactly how he did it. So if anyone ever says to you, there's no evidence that any really smart person believed in a God, just go, actually, Einstein and Newton, maybe the 2 greatest scientists who ever lived, 2 smartest guys who ever lived, both believed in a creating God. Pretty cool, huh? So, and then in your journal now, you've got a section on the characteristics of the moon. Characteristics of the moon. And I want you to stick these on there. And then I'm going to give us a little break and let Mr. Gilbert handle any questions from you. And then after that, our guest will come in. Again, very famous guest. Has visited every year during my astronomy unit. So I can't wait for you to meet. Well, I won't say the name right now. All right, what's the moon like? The first thing is it's about 1/4 of the Earth's diameter. 1/4. The Earth's about 8,000 miles in diameter. So there you go. So the moon is about 2,000 miles in diameter. 1/4 of Earth's diameter. Now, that's a big moon. It's like a 4-to-1 ratio. The Earth is 4 times the diameter of the moon. That's a big moon, though, when it's 1/4 of the planet. 1/4 of the diameter. What's the big deal about that? Well, because of that, it's got a lot of mass for moons, and it's got a lot of gravity, and therefore it has the characteristic of balancing the Earth and causing the Earth to maintain its tilt. So, big deal. Not an accident. God designed it that way. Gave us kind of an above average, a ratio size, diameter size moon. Pretty cool. Okay? So, the moon has a dark section that we see on a regular basis. What is that? On your white sheet, if you didn't get it in your research, on your white sheet, write down what is the material that the dark section of the moon is made of. What exactly is it made of? What's it made of? Now, the ancients, originally, when they looked at the moon, they didn't have telescopes or binoculars like we use and like I use to look at the moon. So they thought those smooth, dark areas on the moon were oceans. They thought it was like the Earth. Those are oceans of water. Well, they got it half right. They are oceans, okay, but they're oceans of lava. That area has been smoothed over by volcanic activity long time ago in the past, maybe shortly after creation. So anyway, the dark, smooth areas on the moon, they're called maria, M-A-R-I-A. That's Latin for oceans or seas. Well, they're seas, okay, but now they are cooled, hardened lava. How about the gravity on the moon? 1/6 of the Earth. So on the moon, you'd weigh 1/6 of what you weigh on Earth. Now, if you weighed 100 pounds here on Earth, what would you weigh on the moon? Well, 1/6 of that. What is that? Well, rounding it, it's 17 pounds. So 17 pounds. So if you were playing basketball and you wanted to dunk, oh my, could you jump out of the gym and dunk the basketball on the moon? So if you could do it. That's why when you see the astronauts on the moon, they kind of bound. That's the reason. Even though they've got a many 100-pound spacesuit on, they can still jump up and kind of hop or bound. And it's because of the 1/6 gravity. I've already said less mass on the moon, and because of all of that, there's something about the moon. When you look at the moon, when you look at it, you see pockmarks everywhere. Some of them are really big holes. What are they? Craters. So the moon has been heavily cratered. Why? Meteorites, asteroids, hammering the moon. Well, it doesn't happen on Earth. Why not on Earth? We've got a thick atmosphere that acts like a shield. But the moon, no atmosphere. Why not? On your white sheet, write a hypothesis why the moon doesn't have an atmosphere. Why not? It's bullet fact. Bullet fact. Why no atmosphere on the moon? Okay, it's got a very thin atmosphere, not a thick atmosphere. Extremely thin. Not even worth mentioning, mostly. So, here's the idea. Since there's no atmosphere, no shield, and so in come the meteorites and in come the asteroids. How about the temperature on the moon? Did you find it anywhere? Now I'm going to round a little bit, but listen to this. It's plus 270 on the sunny side at the equator and minus 270 at the equator on the dark side. Minus 270 plus 270. Wow. What is the boiling point of water Fahrenheit? 212 Fahrenheit. So on the sunny side, water would boil. Oh my. On the dark side, minus 270, like extremely cold. So it's super hot and super cold. Big temperature swing on the moon. So that will impact what we talk about in a little bit, what we need to take with us if we're going to spend some time on the moon, if we could. And then a couple of other things really quick about the moon, then I'll give you time for questions. It's very rocky, so lots of chunks of rock on the moon. And it's got highlands, so it's got the smooth areas, and then it's got highlands. Smooth areas and highlands on the moon. Okay, perfect timing. Little time for questions. Maybe should have done it slightly earlier. There's the 20-minute mark right there. Ask any questions that you have. Okay, I'm back after your questions. Our guest now. Here's our guest. Can I do this? I think so. This is half. Well, it's actually the whole, only the northern hemisphere of the moon, but it's Mr. Moonhead. Now, normally in the classroom, Mr. Moonhead pays a personal visit like this. So, Mr. Moonhead. Mr. C, that looks weird with your reading glasses. Well, I suppose. Okay. Okay, Mr. Moonhead. Now, normally Mr. Moonhead is able to demonstrate a really cool principle, or the last characteristic that I want you to catch about the moon before we talk about traveling there. Okay, so you see the Maria right here, the smooth side. Can I move that in close? So this is the lava, predominantly lava side of the moon. Okay, the other side, more highlands, not as much cratering, and not much lava. Okay, now I want to show you the way the moon rotates. Now watch this. The moon revolves. It goes around the Earth in 27 days and some hours. 27. So it does this. Now, if this were the Earth, I want you to watch what it does. You won't be able to see it exactly. I'll have to tell you. So it's difficult to do if I'm not able to stand up, say, and do this around my brown covered padded stool. Here's the point. The moon always keeps this side facing the Earth. So it revolves one time while it rotates one time. It's got a 1-to-1 rotation to revolution. Huh. Why is that? We don't know exactly, but we think there's a huge concentration of mass right here that the Earth pulls extra hard on and locks this area into place, holds onto it, so it always makes this side face the Earth, and we never see the other side. So that's the dark side of the moon. So we never see that, because when you look at the moon, you're always seeing the same side or face of the moon. Isn't that interesting? And again, perhaps because maybe of a huge concentration of iron on this side that the Earth pulls extra hard on. So a 1-to-1 rotation to revolution. So interesting stuff. Now I want to tell you about your homework. Unfortunately, we're only going to have a little bit of time, maybe to do one question, maybe one group. Now, if two groups have time, Mr. Gilbert will decide whether two groups, evens and odds, can do the questions. Please, as you go back to do the questions, please don't touch the microscopes. They are locked into place. So they're focused for the 8th graders. Please don't touch them. I trust you not to touch them. Okay, aren't you glad Mr. Moonhead visited? He always enjoys coming. So, and this might be the last year he gets to visit. So I may have to somehow permanently put Mr. Moonhead on display somewhere. So I'll have to think about that. I haven't even thought about that. Okay. Well, anyway, I want to just bring up one other thing. So if you're going to the moon, so what do you need? You made a little list. What do you need based on what the moon is like, the characteristics? Well, obviously you're going to need spacesuits that both keep you warm and keep you cool. Now, I assumed you're going to rocket up into space, and then you've got a spacecraft that's going to be directed to the moon. But you need a spacesuit that's going to work really, really well in keeping you warm if you're anywhere near the cold side, or to keep you cool if you're on the hotter side. Now, truth be told, you probably wouldn't go exactly to the hottest place or the coldest place on the moon. It would be in between, but you still need a heater in your spacesuit and an air conditioner. Isn't that weird? So you need a really strong suit, because when you're bounding around or running around on the moon's surface and you've got your big thick spacesuit, if you fall down and rip it open in the vacuum of space, you're going to heaven. So you've got to have a very strong suit, and you've got to be careful. So you need food, probably freeze-dried food. Obviously, you need to take water with you. The moon is mostly dry. There isn't like a supply of water. There's frozen water in a number of places, and we think maybe a lot more than we know about exactly. You'd need bright sunglasses because of the brightness of just the sunlight. So those are some things you would need. Now for homework, it's up on the board, pages 32 to 34. So you're going to read those pages. You're going to use LS6. You've got lesson summary 6. And then you're going to do worksheet 35F. Now, this is one of those worksheets where the top half, you just have to do the multiple choice question. The bottom half, it's where you have true or false. And you know if it's a true statement, you just put true. If it's false, then you've got to correct it. The underlined word you've got to change to make it a correct statement. Don't forget page numbers. So you need page numbers on this. Don't forget, part of your score, one of your last scores this quarter. And then on the back, from page 40, you're going to read page 40 about our Apollo missions to the moon. There it is, Apollo. Do you see that? And I've decided you just need 5 bullet facts from page 40, right there. 5 bullet facts on the back. So the front half, from page 32 to 34 and LS6, and then bullet facts from page 40. Okay. Well, that's it. I'll see you on Wednesday. Mr. Gilbert will answer any additional questions you might have, and you might even have time to do a science activity question. So away you go.